Today I will conduct a short tutorial on drilling and blasting. I will be um, conducting a production pattern design tutorial. And this tutorial will be based on this course book that I have created. The course book is titled Blast Pattern Design in Open Cut Mines using Surpac Mine Planning and Design Software. Right? So this is basically the content of the course. Um, you have the introduction to this course book, the design requirements, and you have the pattern designs, like the first one that I will be conducting now, production pattern design. And then you have other types of pattern designs, trim pattern design, pre-split, ramp design, and then you have the reporting of blast holes, plotting of blast holes, and then last of all the appendix. But my main focus in this tutorial today is designing the production pattern in open cut mines. So, brief introduction on drilling and blasting. Drilling and blasting in any hard rock mine is the first process to free the ore from the in-situ ore host rocks. The degree and the efficiency through which drilling and blasting is done actually determines the quality of the broken metal or even so downstream processing. In surface mining operations, the purpose of drilling into rock is to provide a blast hole into which explosives can be loaded. Good drilling practice includes carefully monitoring drill rig operating parameters, taking careful notes of the changes in geology during drilling, and effectively communicating to the blasting crew any unusual conditions encountered during drilling that may affect blasting results or require changes in hole loading practices. Blast design is not a science, right? But knowledge, experience, studying and analyzing past practice in relation to rock strata and geology, etc. Studying and analyzing past practice makes blaster to achieve perfection. Thus, for a blaster, a valuable tool is the file of the blast reports that he builds as he gains experience. Not only do these provide evidence of the quality of his work, but they also provide a wealth of information upon which he can draw as future blasting situations develop. Okay, the main objective of this course book is not to discuss in detail the theory behind drilling and blasting, but to get one up to speed quickly in utilizing the software tools available to design blast patterns. It is advisable that anyone new to Surpac should at least go through the introduction to Surpac tutorial and the drilling and blasting tutorial. Okay, design requirements for any design in drilling and blasting in Surpac. For any blast design in Surpac, the following are the main requirements one will use to successfully design a pattern. Okay, A is the blast master outline. What is a blast master? Blast master contains polygons or closed strings of pattern outlines showing the shapes, drilling and firing sequence. This is usually designed in advance of any pattern design. It sets out individual blast patterns on a bench and indicates the optimal sequence of drilling and blasting. That sequence aims to achieve budgeted ore tons and grades together with the associated stripping. Blast master design is a separate procedure on its own and won't be discussed in detail, but will be included in the appendix of this course book. B. You should have a good folder structure to store data. It is important that you must already have a folder structure for your design setup already in a common network drive. Below is an example of a folder structure to work from and a brief description of each. Okay. So this is a typical folder structure to store your files. Okay, one right up here, common folder for all drill and blast Surpac files. Then you have folders below, subfolders folder for files by pit name. Okay, these are pit names. Then folder for files by pit stages. Okay? So under the pit, you have pit stages. And then you have folder for particular bench. Under the pit stage, example in stage 2 pit here, you have folders for benches. Like bench 2444, bench 2450, etc. And then inside each bench folders, you have 10 web folders for a particular bench. Number 1 is the blast matter polygon, stores the blast matter polygon, and pre-designed production and removes. Number 2, second folder, design templates. Third, complete pattern design. Fourth, blast report for export to simulation, blast simulation software. Fifth, entry plan code of the pattern. 6, prepared string for survey to set up pattern. 7, pattern sign off and approval receipt. 8, orders pick up by survey before loading. 9, report on blast performance. 10, general web directory. Note that all discussions and web examples in the preceding chapters will be based around this folder structure. Okay, a good understanding of the pattern naming convention. Blast pattern naming. Blast pattern naming is done by blast type, RL, or elevation, and then blast type number. So blast type, different types of blasting for ramps, production train, pre-split, trams, tow, and others. Okay, say under ramps, you will have the RL, and then you have the blast type number. For ramps, blast type number starts from 001-010. Production, you have the RL. Blast type number starts from 011-060. Like example, a trim shot at RL 1900, trim shot here. At RL 1900, we'll have this blast number starting from 061 to 080. So this is the first trim shot for that 1900 RL. It starts at 1900, 061 here. Second one will have added elevation, trim at the elevation will have 1900, 062 up until 080. And then if you go to 081 to 090, that's pre-split. For example, 1900 RL again. So this is the blast pattern naming for that particular RL and blast type. Okay, what is production pattern design? Production patterns are pretty much straightforward. Usually production rules for a particular bench are already designed and stored in the blast master folder for the particular bench on the network drive during creation of blast masters. Only one needs to load the holes and clip the holes to within the outline of the particular pattern IS. Production pattern design is the most simplest because you are drilling from one level to the next level, so your design will be pretty much straightforward. Okay, the holes will already be designed and placed in the blast master folder under that particular bench. Say bench 920, first folder is the blast master folder, so holes will be designed and placed already inside that blast master folder. So, example here, you bring the blast master outline out. This is the blast master outline. Bring the production holes out, then you trim it within each pattern size here. And that should be your production pattern design. So figure here shows the production holes already designed for the pit design 2, which is the pit, name of the pit, and the bench 920 bench. The two patterns pointed out 920-212 here, 920 bench 212 and 920-213. Okay, according to naming convention, production patterns. So 212 example, 212 pattern ID for 920 beds. So RA will be 920, production 920, and 2 will be the pitch stage. This is a 0. If pitch stage 1 it will be 1, 1, 2, but it's pitch stage 2, so 2, 1, 2. Okay, that's how the blast naming is done for that particular bench at 920. Okay, we will start. I will start by first organizing the folder to do a production pattern design for the bench 92212 in this tutorial.